All right, using the unit circle, we want to find the exact values for each one of these functions, and then we want to draw them in standard form. So to draw the angle in standard form, recall that the terminal side is always the 0 angle, and then we draw 210 degrees. And remember that goes counterclockwise. So counterclockwise 180 would be straight out. 30 degrees more would be 210. So we started here, we went around this way, that's 210 degrees. And the exact value for the sine of 210 degrees, so that is a 30-degree difference going down, which means our y value is the same as 30 degrees over here, just in the negative direction, and that would be negative 1/2. So negative 1/2 is your exact value. Again, we look on the unit circle. So here we are looking at the unit circle. It would be the same as 30 degrees, which is 1/2. It's just in the negative direction down here, so it's negative 1/2. Cosine of 330 degrees, we would start at 0. We would go around 330 degrees. All the way around is 360, so if we just go 30 degrees less than that, here is our angle for 330 degrees. Which means we're looking for the cosine, or in other words, the x value out here to the right at 30 degrees. So the x value out here to the right at 30 degrees is square root 3 over 2, and it's in the positive direction, so it is the same. So it's square root 3 over 2. Now we're doing the sine of 735 degrees. So 735 degrees is more than a circle. So if we take 735 degrees and we subtract off 360, that still leaves us with 375 degrees, which means it's still more than a circle. So I'm going to subtract off another 360 degrees. That leaves me with 15 degrees. So now that we have two circles, to draw this in standard form, I would go all the way around once, all the way around twice, so that's my two circles that I subtracted off, and then I would go 15 degrees. So there is my angle of 375 degrees. Now 15 degrees isn't on our unit circle. So we're not going to write an exact value for this one because we haven't learned how to find the exact value for 15 degrees rather than 30 degrees. Right now we have to find the exact values for a tangent of 210. So our 210 degree angle was down here, like this. And remember that tangent of 210 degrees is the same as sine of 210 divided by the cosine of 210. So 210 degrees is 30 degrees past 180. So they would both be negative. The sine and the cosine would be negative. But they would be these values. So sine is 1/2 and cosine is square root 3 over 2. And they're both negative. So sine was 1/2 and cosine was square root 3 over 2, and they were both negative. Now we would simplify this. The negatives would cancel, the divided by 2's would cancel, and you get 1 over square root 3. Now I times both top and bottom by square root 3, making it square root 3 over 3. So here's my exact value for tangent of 210 degrees. Now if we have tangent of 330 degrees, that's 30 degrees less than a full circle. So there's our 330 degree angle. And again, 330 degrees, that's 30 degrees down this way, which means it should be the same as these, it's just the y is negative.
So in this case, it's these same values, it's just the y is negative and not the x. So we'd have negative 1/2 over square root 3 over 2, which would reduce to negative 1 over root 3. And following this same pattern times top and bottom by root 3, and we get negative root 3 over 3. And then our last on the tangent, 45 degrees. So here's our 45-degree angle. And recall that at 45 degrees, our sine is square root 2 over 2, our cosine is square root 2 over 2. And so when we divide these, sine is root 2 over 2, cosine is root 2 over 2. Dividing these, they're exact same thing, so that gives us 1.